I'm going to explain electron configurations to you. And I'm going to use the periodic table as a way of counting, kind of a place counter for where the electrons are going to be. First thing I want to do is I want to put helium right in here, because in terms of electron configurations, it kind of makes sense to have helium situated right there. Now, this block of two columns, the alkali metals and the alkaline earth metals, that is considered the S block, S sublevel. This block over here, right to there, is considered the P block. So that's the P sublevel. This block right in here, which includes the transition metals, is considered to be the D block. And then the F block is all of these inner transition metals. I'm not going to do a whole lot with those. So what I want to do is I want to take an element, and I'm going to show you how we define where those electrons are going to be. I'm going to use phosphorus right there, element 15. Now, phosphorus with 15 protons also means that it's going to have 15 electrons, because at this point I'm talking about configurations of neutral elements. So what I want to do is I want to start building an atom of phosphorus. I need to start at the very beginning. The simplest electron configuration would be that of hydrogen. Now, along this side, these numbers, which represent the periods, they also represent the principal energy level where the electrons are going to be found. So I can kind of go along here and just put down N is equal to. Okay, these are what Bohr originally postulated were the energy levels of the hydrogen atom. So I have N equal from 1 to 7. Now, the principal energy level also defines the number of sublevels. So the number of sublevels equals the value of the principal energy level, meaning principal energy level 1 right here, okay, make that red, I'm talking about principal energy level 1, has one sublevel, and that's the S sublevel, okay? Principal energy level 2 right here has the S and the P, okay? Principal energy level 3 right here has the S, the P, the D. So each time you increase a principal energy level, you get another sublevel. Now there also happens to be a little funny, quirky thing that happens right through here, and I'll explain that, but for right now I want to put, oops, don't want to do that, I want to put 3D, okay, 3D, 4D, 5D, and 6D. So, and I guess since we're at it, I can put 4F down here. Very rarely am I going to ask you to do anything with these down here, and 5F down here. Okay, so let's get back to phosphorus, looking at what we have. The first place I'm going to start in writing the electron configuration for phosphorus, as with every single element in the periodic table, is I start back here at hydrogen, at the number 1 spot. So I'm going to write it this way. I'm going to say, okay, 1, which refers to the principal energy level. The first sublevel I come to are the S's. I'm going to make that right here. Okay, I'm going to hit the S's first. So it becomes 1S. And now I'm going to count over 2 positions. 1, 2. That refers to 2 electrons because it's 2 places in the periodic table, which are for protons, but it also works for electrons. So my first symbol It's going to look like that, 1s squared. It doesn't mean 1s squared, it means 1s2, which refers to principal energy level 1, right there, okay, sublevel S, right there, and then number of electrons, which is going to be 2 right there. Okay, so I'll get rid of those because I don't want those sitting there. That's what, oops, took too much of the S. Now, after I've just completed the S, if you see here, there's nothing left in that row. Nothing is there, okay? So I need to go down to the second row, right here, n equal to 2. So I'll put 2 right there. The first sublevel I come to are the S's, so it's 2s. I kick over 1, 2 spaces referring to 2 electrons, so it becomes 2s2. Now, I just go along here, nothing going on until I get to this point right there. That refers to the 2p, the beginning of the 2p sublevel. This is 3p right here. This would be 4p right here. This would be 5p, 6p, and then 7p. Okay, so I'm right there. I'm starting right here. So I'm going to write 2p, and I want to get ultimately to phosphorus right here. So I'm going to count over 1, 2, 3, 4, 5, 6. So it's 2p6. That is the maximum number of electrons the p sublevel can hold. Got to remember that the p sublevel has 3 orbitals. You can hold 2 electrons per orbital, so 2 times 3 makes 6. Well, now I'm down to n equal to 3. Okay? So my next place I'm going to come, I want to get rid of this guy because he's in the way. Just remember those are the F's. Okay? So now I hit principal energy level 3. Again, the first place I'm referring to with these two are the S's, sublevel S, so it's 3s. I'm kicking over 1, 2 spaces. That refers to 2 electrons there. Now I have empty space right here, nothing there, till I come to the 3p. So that's going to be my next sublevel, 3p. I count over 1, 2, 3 places, so it is 3p3. That is the electron configuration for phosphorus, kind of a shorthand notation. You can always check it, because if you add up 2 plus 2 plus 6, which is going to be 10, plus 2 more, plus 3 more, that equals 15. Okay, 15 electrons. 15 electrons has to equal the atomic number 15 right there. And there's also a way that you can do a shorthand for phosphorus. What you do on a shorthand configuration is you go back to the preceding period. Okay, here's phosphorus right here that we're talking about. You go back to the preceding period. Well, that's period 2, this row, and you write the noble gas. It has to be the noble gas, so it's neon. So what I would do then is I would put neon in large brackets like this. What that represents is that, phosphorus has what's called the kernel of electrons that neon does. And then I pick up where I left off. Here's neon, then I go over, okay, I'm going to start right here at principal energy level 3. So 3, again, the 1, 2 in the S's, so 3s2. Then go across to the 3p sublevel, and I'm going 1, 2, 3 right there. So that's another way to write electron configuration for phosphorus. So to remind you what's going on, okay, let me take this again. The S, I'll write it down here. S sublevel has one orbital. And every orbital can have a maximum of 2 electrons. Maximum of 2 electrons. Okay, so with one orbital I'm going to get 2 electrons in it. So that counts. There's 1, there's 2 in the S. Now the P sublevel has 3 orbitals. 3 different orientations in space off the X, Y, Z axis. So it can contain a maximum, because 2 electrons per orbital, of 6 electrons. And so that would include, you know, this 1, 2, 3, 4, 5, 6. Okay? You get over to the D's. These have 5 orbitals. They can hold a maximum of 10 electrons. See how that works. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The last sublevel is the F. They have 7 orbitals. That means you're going to be able to put a maximum of 14 electrons in there. All right, let's see if that works. 1, 2, 3. Oops, I may be doing this wrong. Well, let me see. Sometimes those are counted. Sometimes they're in there. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Yeah, I messed that up. I was thinking about that. Here's what's going on with that. Different periodic tables are different how they're represented. The lanthanide actinides go right up there. So they're actually in the D's. Then the F's, so I got to correct that. The F's start right here. Here's 4F. Oops. Save this link. What the heck? Get that out of there. Save link. Oh well. How come I can't draw anything? That should have been a 4. 4F there, 5F there. I said there's kind of a reason why we don't mess with those very much. But here I go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So I hope this is going to help you when you do electron configurations.